Okay, shh. So here we have we got a positive charge, negative charge, and they're 1 meter apart. So determine the point other than infinity at which the total electric field is 0. Okay, so look, the equation that works here, the equation we're using here, when you have a charge, let's say it's just a positive one, the electric for positive charges, the electric field goes out in all directions. So if you, out in all directions like that, if you want to find the electric field at a point r, a distance r from the charge, we'll say that this guy right here is big Q. This is charge Q. The equation is kq over r squared. So other than infinity, if r is infinity, then E goes to 0, right? Like if you're just like super far from the charge, so far that you call it infinity, the electric field would be 0. So yeah, they're saying you can't just be like, oh, the answer's infinity, which would be an answer. They're just taking that answer choice away. So how do we solve for the point where the total electric field is 0? Well, here's what you do. So you got to first identify, is it going to be here, here, or here? And I know we already did this, but not recorded, so I'm going to explain it again. But I realize to help explain this, I'm going to make, let me grab this charge, and I'm going to make him big. Because he's bigger, right? That guy's big, dude. He's a big charge. Right? Scoot him over a little bit like that. So, so we'll call this guy charge 2. He is 6 microcoulombs. So he's a big guy. Now look, pick somewhere in the middle, anywhere in the middle, right there. So we'll call this guy charge 1. This guy's charge 2. Which way is the electric field for charge 1? Well, electric fields go in to big negative, like this. So anywhere in the middle, the electric field for charge 1 points to the left. Which way does the electric field for charge 2 point? Well, for positive charges, the electric field goes out, right? Like that. So anywhere in the middle, the electric field from charge 2 also points to the left, right? It's going like this. It's going out to the left. So are these guys ever going to cancel to 0? Never, ever, ever, ever. So it can't be in there. It's not going to be in the middle. Okay, let's check to the right. So now let's check somewhere over here. Well, which way is the electric field? Anywhere over here. Which way is the electric field for charge 1? To the left, because electric fields go in to negative, right? It's going to the left. All right. Which way is the electric field for charge 2? Well, charge 2 is positive. The electric field goes out, so it's going to the right. So you, at first, you might look at that and you're like, oh yeah, I found it. No, you didn't. There's absolutely no way for those electric fields to cancel. They're not going to cancel. Because why? Charge 2, our big positive guy, notice that he's what? Bigger. So at this point right here, the big guy has 2 advantages. What are the 2 advantages that he has? He's bigger and he's closer. Just look at the equation. E equals kq over r squared. He's bigger and he's closer. So there's absolutely no way for E1 to cancel E2, right? Okay, so where must the location be? It's got to be somewhere to the left. It's going to be somewhere over here. And dudes, you know what? On multiple choice tests, if you just look at the situation, you look at the answer choices, if only one of them is over here, then guess what? You found the answer. You don't even have to calculate it. I've seen that a lot on tests. Like they have answer choices where only one of the choices is over here. So it has to be, that has to be the answer. Okay, so over here, which way? So we'll call this guy charge 1. This guy's charge 2. He's minus. He's plus. Which way is the electric field for charge 1? To the right, right? Because electric fields go into big negative. Which way is the electric field for charge 2? To the left, because electric fields go out from positive. It goes to the left. Okay, so now let's put our distances down. Let's say the distance in here is x. So then that means that this distance will be x plus 1. Right? So those are our distances. And we're basically solving for x. So what needs to be true? E1 and E2 must be what? Equal. Or in other words, you know, if you E1 minus E2 must add up to 0, because that's what they say right here. The total electric field is 0. All right, so E1 equals E2. Now what's the equation for electric field? K Q1 over what? R squared. What's the distance for charge 1? X. That'll be x squared. Equals K Q2 over x plus 1 squared. The k's cancel, and the rest of this is just algebra. The only thing missing is x. Okay, so now you're going to have Q1 times x plus 1 squared equals Q2 times x squared. Now what I would do is take the square root of both sides. So that's going to give x plus 1 square root of Q1 equals x square root Q2. So now let's distribute the Q1. So let's see, this is going to be x square root Q1 plus square root Q1 equals x square root Q2. Plug the numbers in. I'm almost out of time here. X comes out as 1.8. 1.8 meters to the left of the negative charge.